Semiconductors are one of the most influential materials in modern history, powering up not just smartphones, but fridges and electric toothbrushes as well. It is used in the vast majority of electronics that we use every day, despite being such a simple material. So in this video, we will explore how regular conductors work, how semiconductors work, and their applications in technology. Let's start with atoms, which make up everything around us. An atom contains electrons around it, which exist in different energy levels, called shells. Electrons closer to the center, or the nucleus, of the atom has less energy than the electrons further away from it. This outermost energy level is called the valence shell, and the electrons that exist in the valence shell can easily break out of this energy level to become a free electron. Free electrons can easily pass electrical charges through them, making them great at conducting electricity. This is why many metals, such as copper and silver, are fantastic conductors, since they have plenty of free electrons. These materials also have very little resistance to interrupt the electricity flow, which means that electrons can easily move through them without bumping into anything. Of course, materials that don't easily let go of their valence electrons, such as rubber, are insulators because they prevent the formation of free electrons. So now what about semiconductors? Here is the fun part. They are sometimes conductors and sometimes insulators. These materials conduct better than insulators, but not as well as conductors. The most famous of the bunch is probably silicon, which is an insulator at room temperature. However, when we heat it up, it becomes a conductor, which means that we can control when it is insulating or conducting. When we add energy, or heat, we force many of its electrons in the valence shell to become free electrons, making it a conductor. When it cools back down, the free electrons will return to their appropriate energy levels, turning the silicon back to an insulator. This is a very simplified explanation without going into energy gaps and quantum mechanics, so please keep that in mind. So why do electronics care about semiconductors? One of the most crucial parts of any electronic device is the transistor, which is a very small switch that controls the flow of electricity. By combining many of those switches together, computers are able to perform basic calculations or simulate the aerodynamics of a cow. By simply heating up specific transistors, which are mostly made of silicon, we can make them into conductors, switching them on and allowing them to carry electricity or store information. When we want those transistors to turn off, we just need to stop heating them, and they will return to being an insulator. Modern electronics can range from having thousands of transistors to billions of them, and anything that connects to electricity will likely have some number of those semiconductors. And there we have it. Conductors are able to allow electricity to flow through them by having plenty of free electrons. For semiconductors, we can manipulate them to be conducting or insulating by controlling how many free electrons they have. We use this technology to create complicated electronics through billions of transistors, making our world run the way it does today. I hope that y'all have learned something interesting today. Thank you for your time, and stay hydrated.